Hello everybody, we're here at Diamond SA in the south of Switzerland in Lausanne, and today we would like to talk about a technology, the power solution, power connectors which we produce. And next to me is our expert for these technologies, and we would like to talk a little bit about what is it. So my first question, can you in a few words explain what we understand as a power solution?
Okay, power solution is a technology we developed in the year 2000 as an answer to the increasing power our customers were putting into single mode fibers. So at that time it was found out that if the optical power exceeds a few hundreds of watts, they could lead to the failure of the connectors. The mechanism is the fact that dirt particles, contaminations that are on the fiber core can absorb light transmitting through the fiber, and this light that is absorbed is converted into heat, and the temperature of the connection can get higher than the melt temperature of glass. So at this point what happens is the fiber core just melts and there is no more light going through the connection. And moreover, what also can happen if the power is high enough is this damage, this local damage can propagate through the fiber, and it can lead to a total failure of the fiber itself and of the laser as well if no one would switch off the laser in time. So our answer to these problems was the development of these PS connectors, which allowed us to send higher power through single mode fibers. The solution worked through enlarging of the mode field diameter of the single mode fiber. This reduces the power density, and the reduced power density means there is no risk of thermal failure, and higher power can be transmitted successfully. These connectors have been tested up to 6 watt without any problem.
Okay, you're always talking about the temperature as a problem. To what temperature range can these power solution connectors withstand?
Okay, they've been qualified from -40 up to 85 degrees C. They also been qualified in damp heat conditions according to Telcordia and to IAC spec. They also been tested in continuous use up to 2000 hours at 6 watt without any failure.
Okay. Another point you were talking about is cleanliness. You said that dirt turns into temperature, but simply said.
Yes.
Why do we have to take care of this?
Cleanliness is very critical. Even if we use high power connectors, we have to make sure there is no contamination. There must be no large contamination on the fiber core. For this reason, we suggest our customer to make a visual inspection and even, if necessary, a cleaning of the fibers, of the fiber surfaces before every mate and demate cycle. And one other important thing is also, we believe, the use of an interlock, meaning a device that would switch the laser off if something wrong happens along the fiber. So this can be implemented, for instance, by introducing a monitoring of the output power. If this output power drops, it means something is going on, so the laser should be turned off immediately.
Okay, I see. And is it dangerous to use these high powers?
Power solution connectors are typically used in combination with with class 4 lasers. So yeah, that's critical. Safety eyewear must be used, as well as laser safety procedures. And additionally, we must note that PS connectors have got a way smaller numerical aperture than single mode connectors. This means the output is almost collimated, so it can be dangerous at higher distances.
Okay, I see. Yeah. There is another physical property which is connected to these lasers and the powers, and that is polarization. Can we combine this high power solution with polarization maintaining fibers?
Yes, we can. This is called PMPS connectors. PMPS connectors combine high power and polarization maintaining. It's a technical challenge to enlarge the core of a PM fiber without affecting the PM characteristic of the fiber itself. But we achieved it, and we are able to offer PMPS connectors with an extinction ratio of 23 dBs and an insertion loss below 0.8 dBs at 1550 nanometers.
Okay, I think it was a long-term process to develop these connectors. Which values can we realize in power today, and where are we aiming for?
Okay. The initial version, as I said, was qualified up to 6 watts. Last year we developed an enhanced version, which contains enlarges the fiber diameter twofold, yet again in comparison to a standard PS. We call that PS Plus connector. You can find it on our website. And this has been qualified up to 16 watts. And it's only available as a PC Polish connector for technical reasons, but yet it offers return loss above 50 dBs. Then we are also been investigating connectors for even higher power on single mode fibers. But at a certain point, the connection losses begin to be a problem. I mean, the light that gets lost inside the connector to insertion loss is higher if you increase the power, and you get at a certain point that this loss will just melt away the connectors. And for this reason, a different connector mechanics must be developed, and that's currently at the forefront of our development.
Okay, I see. Well, basically, we're talking always single mode fibers and multi-mode fibers. What is the difference if we're talking about high power between single mode and multi-mode fibers?
Single mode fibers, the most critical point, as I said, is the power density. So that's the reason why we enlarge the mode field diameter. On multi-mode fiber, the most critical point is not the power density, because you have higher powers, but you have way larger diameters. So the main problem is the absolute power. The absolute powers can be up to a few hundreds of watts on multi-mode connectors, and this turns into heat inside the connection. So we developed a solution for multi-mode fiber, which consists of a connector with reduced insertion loss, typically 0.1 dB, in order to reduce this dissipated power. And also we have a connector body and mating adapter that dissipate the heat that is originated inside the connector. It dissipates it outside. So this way we can withstand up to 100 or up to maybe 500 watts as well. This is called PSM connectors. M stands for multimode. We also developed a connector for laser interface to be used on lasers. This is based on the proven SMA connector interface, and it resists up to 200 watts, and it's available both as a mode stripper and as a mode guide connector, depending on whether the customer needs to strip the cladding modes outside of the fiber, or the customer wants to guide all modes, including gallium cladding modes, to the opposite end of the fiber.
We cannot talk about the clients, but we can roughly talk about the projects we had. One was with a world-famous company. I think it was in data warehousing and data centers. Could you say a few words about it?
Yeah, this is the project that led us to the development of this connector, because it was the real market request at this point to have the 16 watts connectors that came to us because of our experience on the 6 watt versions. That was a milestone for us to be able to go from 6 to 16 watts.
Okay, another project was in 3D scanning, where we also need relatively high powers for the outdoor scanning. and in distance measurement, where you can achieve by these high powers very precise measurement, because you have a very precise distance for the light. You can measure very precisely. Another one was fiber amplifiers with high optical power. Do you remember there something about this project?
Yeah, fiber amplifiers are a typical application because there you have high power, as well as WDMs modules where you combine lasers, and if you sum up medium powers, you get high powers too. So these are typical application for PS connectors.
Okay.
As well as undermarine transmission fibers, where you also have high power, high channel density.
Okay, and another one which is obvious is for outdoor applications, because if it's outdoor, you have a high risk of pollution. So then these fibers get dirty, and even with lower power, you can have a problem there. So you can apply the same technology if you are in outdoor or in dirty surroundings, and that helps. I would like to summarize a little bit where are typical applications where we can use these power solutions. So one is spectroscopy, where you have high power and long distances. It's in medical, where you also need high power for surgical or other applications where you need high power at the end of the fiber. Obviously in space technology, because they have to be very reliable, and it's long distance, so it's high power. In interferometry as another typical application. As we already mentioned, the example, data centers, the bigger they get, the more power you need. And even in telecommunication, if it is long distance with high losses, you have to enter with high power, and also there you can use our technology. We have excellent samples. You can have a look on our website, or you can always contact us for further information. Thank you very much for your attention.
Thank you.